Hello and welcome to the first installment of our flipped classroom activity. My name is Ashok and MGM Dr. Jiva Patikar College of Computer Science and Information Technology. Right then, the topic is CPU scheduling. In that, the concept first come first serve scheduling. This concept belongs to the operating system in the domain information technology. Let's begin with. By the end of this presentation, you will know exactly the first come first serve algorithm and partially get familiar with the operating system role also. Key concepts covered in this video, and let's get started with process. Process is a program in execution. At the time of execution, in process life cycle, there is many stages. Out of which here we mention some stages, that is new, ready, and running, and terminate, and waiting. So these are the minimum sort of stages. So new, it means the created new, and after that the ready, and after that it go through running and get terminated. This is the easy simple step in single CPU. They are going on and lastly terminated. There is some waiting step also. But in new state and in ready state and in running state, there is the program inside the CPU. For that, see the next diagram in this slide. Here is I mentioned CPU like this, but in the system it is not like this. So here is a hard disk, and here is a main memory, that is the RAM, and here is the CPU, and here is the mentioned waiting step. So here is some processes P1, P2, and P3 like us. They reside in secondary memory. The long-term scheduler choose and create new process and pull into main memory. So long-term scheduler LP, it also degree of it also schedule the process, and it controls degree of multiprogramming. And once the process is in main memory, here is a short-term scheduler comes into picture, and short-term scheduler choose one process from ready queue to schedule it for execution purpose into CPU. And here is the waiting set. Maybe there is some process required resources at that time. The resource is not available, then the process comes into waiting set, and again that schedule is into ready state. Again from running to it come into ready, and again it's going to execution purpose in running state. If the process have no required resource free, suppose memory, or here is some newly arrived process have the higher priority compare these waiting or suspended processes. So if the resources not available, then suspend it and go into suspended waiting state, and then multi scheduler is come into picture, and they swap that process into other. After maybe if the process is actually required again execution, then the long term it scheduled into again into main memory, and likewise this execution happens. Here is broadly I mentioned this thing in this diagram. So let's see the next CPU scheduling. It means pick up one process from ready state to run state or maybe run to ready. Likewise, the scheduling happen. So who will do the scheduling? So you see in broad picture uh, some short term and long term and medium term decided, but without help of algorithm they not schedule actually. So what does this what does do? uh, Whenever the process need to move from one state to other state at that time, these uh, long term, short term and medium term uh, do the scheduling, but they need the help from round robin and uh, first come first serve and shortage of algorithms. So there is two type of scheduling mode. One is the primitive and another one is the non-primitive. In primitive, once the process it, it allows CPU allow, in primitive uh, it allows the process execution until uh, until it's finished, or maybe it again uh, it allows the execution to its end or stop in between whenever the some execution happens, and free the CPU to next higher priority or newly arrived process. So the current process primitive and switches to the next higher order priority process. And non-primitive means in non-primitive it not primitive or switches in between when the execution is going on. It allows the execution up to the end once the CPU hold. So in this non-primitive fashion, the first come first serve and shortest job algorithm, and in pre-primitive the round robin and priority scheduling. Let us now you can get the idea about first come first serve scheduling. Let's see its example. Here is a given table. In that 5 process, and here mentioned some arrival time, and some here its burst time, and some here mentioned arrival time. Suppose process P1 arrive at 0 and its execution time is 2, like with all the processes have the time. So first come first name indicates that whatever the process first coming we schedule for execution purpose, and the mode of execution is non-primitive, means once we schedule this particular process it not uh, switches until it not finishes its execution time, that is in this case it is 2. So we can see through the Gantt chart its execution. So at 0 time, at time 0 the process P1 is arrived and we schedule that. After it required 2 unit time, and then which is next process going to be scheduled, which is come the earlier out of this within 2 times the process P1 and process P3 also coming. So out of which we schedule, we can schedule process 2, and process 2 required again 1 unit of time, so it required total 3 unit, and it starts its execution at first process finishes immediately, second process starts its execution. After that process 3 is comes into picture, and it starts its execution 3 unit time and finishes 6 unit time. Why he finishes 6 unit time? Because the process 3 required 3, its burst time is 3, so 3 plus 3 it required 6. Likewise process 4 required 4 unit time, 6 plus 4 10, and likewise process 5 required. So in this way the P1 required 2 and P2 required 3. The P1 process completion time is 2, P2 3, and P3 is 6, and P4 is 10. So we mention that completion time in this column. So P1 2, P3, and P4 and P5. So next step is the turnaround time. The turnaround time means the time spent process in a system, that is called turnaround time. Turnaround time means completion time minus arrival time. So that whatever the time spent in the system, we consider that the turnaround time. In other words, the turnaround time from ready up to till its end, whatever the time spent in between ready queue to termination, whatever the time spent in that stages, that time is known as turnaround time. Here is the P1 required 2 means CT minus 80, 2 minus 0 means 2. So the process come at 0 time and it spent total time is 2. Its turnaround time is 2. Likewise, process 3 required 3 minus 1. So it come after 1 somewhere here, and from that he wait 1 minute, and after that he execute and 1. So 1 it required 2. Likewise, its total spent time is 2. Likewise, process 3 required 4, and 4 required 7, and 5 required 11. Next step is, once we know the turnaround time, we can find the waiting time. So waiting time, the turnaround time is equal to waiting time plus burst time. Total spent time in system is equal to whatever the waiting time and the burst time. The total time is turnaround time. Means the turnaround waiting time is equal to then waiting time is equal to turnaround time minus burst time. So we can minus this process P1 have 2 turnaround minus from 2 is exactly waiting 0. So whatever the process we come immediately we schedule it. Likewise, process 2 have 1, and process 3 have 1, and process 4 and 5 have 3 and 6. So once we know the burst time, completion time, turnaround time, and waiting time, how we can find out average time? Through this prepared Gantt chart, we know the completion time, and once we know the completion time, we can find the turnaround time, and once we know the turnaround time, we can find out waiting time. So how we can find out average time? So we can just add process P1 plus process P2 plus process P3 plus P4 and P5, and it divided by 5. So average turnaround time required 5.2, and average waiting time required 2.2. In this way, we see the first come first scheduling algorithm, and here I don't get confused. Just use this and understand this formula, then you can able to find out. Once you know the Gantt chart, we choose the first one because it's on the criteria of arrival time, and if the both processes have come on same time, suppose P2 have arrival time 1 and P3 have arrival time 1, then out of which we can choose, so which one have a earlier ID, that we can choose for execution concern. That is the first come first serve algorithm. So we see if P1 requires 2, and at that time suppose P1 is not present, P1 coming here, so the system get idle on that some time, because there is no processing ready queue. So likewise, this first come first serve algorithm. Okay, we stop here. Thank you.